Today, we're diving into something that could literally redefine our future. We're talking about the convergence of two powerhouse technologies, artificial intelligence and quantum computing. Now, this combination promises breakthroughs we can barely even imagine, but it also carries risks that absolutely demand our attention. Look, we've all heard the warnings about AI, right? It's a conversation that often feels like it's been ripped straight out of a sci-fi movie. Elon Musk dropped this bombshell comparison way back in 2014, and believe me, the debate has only gotten more intense since then. But what if I told you there's something else bubbling up? A technology that could take AI's power and not just amplify it, but give it a massive, almost unimaginable supercharge. Okay, so before we get into the really wild stuff, let's just ground ourselves in the current AI dilemma. It's a debate that's already at a fever pitch, even without adding any new variables into the mix. 10%. This number is, well, it's staggering. When AI researchers themselves were asked about the probability of human extinction because we can't control AI, the median answer was 10%. Just let that sink in for a second. The very experts building this technology are assigning a 1 in 10 chance of a catastrophic outcome. And the reason they're so concerned is this insane exponential growth. We're talking about AI capabilities literally doubling every few months. This trend is pointing towards a future that some people call the singularity. That's the hypothetical moment where AI's intelligence doesn't just match, but rapidly rockets past the combined brain power of every human on Earth. So, you've got this AI rocket ship, right? But now, a total wild card is about to enter the game. And this wild card could change absolutely everything. This is where our story takes a hard left turn into a whole new dimension of computing. Yeah, as physicist Michio Kaku says, this isn't just about making our computers faster. Not even close. We're talking about building a completely new kind of machine that operates on the fundamental and, frankly, bizarre laws of the universe itself. You know, the best way to think about this is with these analogies. The leap from a normal computer to a quantum computer isn't like building a faster horse. It's like inventing the airplane. It's a total paradigm shift. It's not a better candle, it's a light bulb. It's an entirely new technology built on a much deeper understanding of how reality actually works. And look, this didn't just pop up overnight. This journey started over a century ago with Max Planck. It continued with the totally mind-bending idea of entanglement back in 1935, and then computing genius Alan Turing even envisioned it in the 1950s. Every step, especially Peter Shor's game-changing algorithm in 1994, has brought us closer to this new era. All right, so how on earth do these things actually work? To get it, you kind of have to embrace the pure weirdness of the quantum world. This is where reality starts to feel a whole lot like science fiction. Check this out. Physicist Shohini Ghose uses a simple coin game to explain a core quantum idea. Imagine this: 3 rounds. The computer flips a coin, then you flip it, then the computer flips it one last time. If it's heads, the computer wins. Tails, you win. Fair enough, right? On a normal computer, your odds are 50-50, but on a quantum computer, the house wins, almost every single time. So how is that even possible? Well, the quantum computer is basically cheating, using a wild principle called superposition. See, a normal computer bit is either a 0 or a 1. End of story. But a quantum bit, or qubit, can be both at the same time. It's like a spinning coin that's both heads and tails at once. This lets the computer explore every single possibility simultaneously and then nudge the odds up to guarantee the outcome it wants. And if that wasn't weird enough for you, there's entanglement. This is the one Einstein famously called spooky action at a distance. You can link 2 particles, and whatever you do to one instantly, and I mean instantly, affects the other, even if they're on opposite sides of the universe. It sounds impossible, but it's real, and it's the key to developing things like completely unbreakable encryption. So you take the insane learning power of AI, and you bolt it onto the mind-bending computational power of a quantum computer. What do you get? Well, you unlock 2 very, very different futures. And that, right there, is the central dilemma we're all facing. I mean, just look at this. On one side, you have a golden age of discovery, curing cancer, solving climate change. On the other side, you have a new era of threats, breaking every piece of encryption that protects our society, supercharging AI's ability to create chaos. It's the exact same technology. It just depends on which door you open. Let's focus on the promise for a second. Quantum AI could solve problems that are just impossible for us right now. It could simulate how molecules interact with perfect accuracy, something our best supercomputers can't even dream of. That means designing a drug that targets a cancer cell with surgical precision, or inventing a new material for batteries that makes renewable energy storage basically limitless. The potential is breathtaking. But here is the other side of that coin. Remember Shor's algorithm? Well, that's the skeleton key. It proves that a powerful quantum computer could smash through the public key encryption that forms the bedrock of our entire digital world. Everything from your bank account to top secret government communications would be an open book. And as you can imagine, this kind of power isn't just being developed in some quiet university lab. Oh no, this has become a full-blown global race. The goal is something called quantum supremacy. That's the milestone where a quantum computer solves a problem that no classical computer could practically solve in our lifetime. And it is a fierce race. Just look at the kind of money being poured into this. Nations are investing billions because they know that leadership here is absolutely critical. And you can see from these numbers, China isn't just playing the game. They are betting big, viewing this as a cornerstone of their entire national strategy. Because of these massive national security implications, you're not seeing a lot of collaboration between the key players, especially the US and China. This isn't about sharing knowledge anymore. This is a technology that countries believe they must dominate, not just participate in. The stakes just couldn't be higher. That's why everyone, governments, tech giants like Google, and tons of startups are all pouring resources into getting there first. The winner of this race could potentially control the future of information, security, and power. So we're left with a question that's so much bigger than just the technology itself. It's about us. As we create machines that are designed to outperform us in every conceivable way, how do we redefine our own place in the world? We are standing right on the verge of this revolution, and you really have to ask, are we prepared for the strange, quantum-powered world we're about to create?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.